welcome to all. This is Jayalakshmi from CSA department in PSM College of Engineering and Technology. Today we discuss about a topic Kruskal algorithm, which is available in a subject Design and Analysis of Algorithm. So introduction to Design and Analysis of Algorithm. First, what is algorithm? So algorithm is a set of steps to complete a task. For example, we take a task to make a cup of tea. So what are the steps are needed? Initially, we add water and milk to the kettle. Then boil it, add tea leaves. So this is the second step. And third step, add sugar and then serve it in a cup. So these are the steps are necessary to make a cup of tea. Like a way, algorithm is a steps to complete a task. So every task is needed to some steps to make a process in successful. So what are the characteristics are available to make an algorithm? First, initially must take an input. So must give some output. So yes or no values, etc. So definite sense, in the sense each instruction is clear and unambiguous. So finiteness, algorithm terminates after a finite number of steps. So if suppose we take number of steps, we must complete the task. Then effectiveness, every instructions must be basic. Basic in the sense, if suppose if any beginner come and learn the algorithm, they can easily understand the instruction. Then only they can make algorithms and programs very easily. Now we go for Kruskal algorithm. So first, before that, we discuss about spanning tree. Why we are choosing this spanning tree? This Kruskal algorithm is used to find the minimum cost of a spanning tree. So that before that we discuss about spanning tree means what? So a spanning tree is a connected graph using all the vertices in which there are no loops. So what is the meaning? The next slide I will explain clearly what is vertices and what is edges. Then only you can know how we are make the spanning tree without loop. In other words, we can say that there is a path from any vertex to any other vertex but no loops. This is the concept available in spanning tree. So this concept is implemented with the help of Kruskal algorithm. Okay, so some people they know what is edges, what is vertex, but the rest of the people also they must know. Then only they can easily identify or understand the concept of Kruskal algorithm. So here I give one example, basic example. Some nodes are connected together. So A, B, C, D, E, F, G, H and I. These are the nodes are available in this graph. So this is no need for connecting this much amount of nodes in this example. Suppose we need to compress it, you can choose 2 or 3 or 4 nodes, that's enough. For in my example I am choosing A to I nodes. Okay, so now we are connecting all the nodes with the help of some edges. For example, if we are connecting A to B, some weightages are assigned for this edges. So A and B are called vertices. Not only A and B, we choose A, B, C, D, E, F, G, H, I. All the things are called as vertices. So what are the edges? These connecting elements. That is, if A and B are connected and a weightage is assigned between A and B, that is called weightage and edges. Okay, so now we go for our Kruskal algorithm. So I am choosing this example A to F. So A, B is connected and the weightage is assigned for A, B is 3. Like a way, B, C, the weightage is 1. C, D, the weightage is 6. DE, the weightage is 8. EF, the weightage is 2. And EA, 6. Likewise, we connect all the nodes together with the help of some edges, and some weightages are assigned to the edges. I think you are all clear about it. What is vertices A, B, C, D, E, F? These nodes are called vertices. What is edges? When we are using a line between A to B, that is called edges. And what is weightages? 3, 1, 4, 5, 2, 6, 8. Different weightages are assigned for connecting these nodes A, B, etc. So, I think you are all very clear about it. What is vertices? What is edges? And what is nodes? So, in this graph, it contains 9 vertices and 14 edges. So, the minimum spanning tree formed will be having 9 minus 1, totally 8 edges. Okay, how we are working with this Kruskal algorithm? So, don't think about this is very tough. It's very simple concept. I choose a tabular column. 3 contents are available in header. First thing is tree edges, and second one is sorted tree, and third one is diagram. Okay, so in the previous edges, you go for the previous diagram. A to B, the weightage is 3. And B to C, the weightage is 1. Okay. So what I am doing in the next tabular column, initially I am sorting the weightages in the nodes as edges as etc. For example, initially we assign tree edges nil. Okay, because initially the process is started 0. So you don't need to assign any values or weightages in this tree edges. The next column you choose sorted tree. What is sorting? We can make the things in ascending order, otherwise descending order, that is called sorted. So here I am choosing ascending order. So from the values, the weightages are ordering from minimum to maximum. For example, you look at here, BC is 1. I show it in your graph, BC. 2 vertices are connected and the weightage assigned for BC is 1. This is I included in this next tabular column. Like a way, EF is 2. You see EF value is 2. So I assign the values, ordering the values from lower to higher. So I am choosing BC 1 weightage is first and EF 2 weightage is second and AB 3 weightage is 4. Suppose 2 values are equally available in this graph, no problem, you can choose any one of the value. Even if it is BF4, next you go for CF4. Otherwise first you choose CF4 and then go for BF4. There is no conditions for arranging this one. There is no restrictions for this. Okay. So what I am doing initially, sorted tree. First BC lower weightage. So I assign in the first position. And EF is the next level weightage value. So assign in the second position. Like a way, I ordering all the values weightages from lower to higher. So 1, 2, 3, 4, 4, 5, 5, 6, 6, 8. So this is the sorted tree method initially. So I am not doing anything in the first step. I just make an arrangement from lower to higher. There is no diagram for initially because we can perform only sorting operation here. Okay, so this is the next step. What I am doing from the sorted tree, that is the second column, I choose the minimum value BC that weightage is 1 that comes to the tree edges in the second row of the first column. Look at here, BC1 comes to left. Why I am choosing the lesser weightage value in the tree edges. The rest of the elements in sorted tree, there is no changes. You just keep all the elements in the second column. So you don't need to change anything in the second column. So what I am doing initially, I just choose BC, the minimum weightage value, and keep the value in tree edges second row. Okay, now you go for the diagram session. I just draw the vertices BC and connect the vertices via edges and assign the weightage value 1. I just collect it from the tree edges. Nowhere I am taking this. I just choose the first minimum value BC and draw the diagram initially. Okay, so this is the first step. Now we go for the third row. What I am doing? I am choosing the second value EF. This is the second lower weightage value, that is EF. So I move from sorted tree to tree edges, next row. So here the rest of the elements AB weightage 3 and BF weightage 4, CF weightage 4, AF weightage 5, every elements are placed in the middle. So now you come to the diagram sessions. Already we draw the BC vertices with a weightage 1. Now we include one more weightages. What are all the second things we are choosing? EF, that minimum weightage value is 2. So I draw the second vertices and connecting the edges and assign the value to here. You don't need to connect these two vertices and diagrams joined together. You don't worry about it. You just draw what are all the terms available. You make a graph, that's enough. Now you go for the third session, AB3. What we are doing? Initially we choose BC1 in left hand side and EF2 in the next row. Next we go for AB3 in the next column. Why? This is the third lowermost value. The rest of the sorted tree, you just make the previous steps again. You don't need to change anything here. We just move the minimum value from the previous row and assign the value in tree edges. AB3. Once again you come to diagram session. BC already available in the previous diagram. BC and EF with lowermost weightages are available. Now I am connecting AB. Already BC is available. I just connect A with B and assign the weightage value is 3. I think you are all clear about it. I just connect AB with the weightage value of 3. I go for next session. I think you are all clear about it. You can easily answer it. What is the next value? BF4 is the minimum next value. So we move it to the next row in the tree edges. So I go for the tabular column. BF4 comes to left. The rest of the CF4 and AF5, BD5, CD6, AE6, DE8, there is no changes. You just write it in the sorted tree. Now what I am doing? Initially in the first diagram we just placed only BC, and the next diagram we can connect EF, and the third level we can connect A with B, already is existing one. Now we connect BF. Okay. Is there any loop is available? What is loop? It's a closed path that is called as loop. Still now there is no loops are available. Why? All the places are opened. There is no connection between A and D. Then only suppose if you are connecting A and D, it's a closed loop. Suppose if you are connecting C and F, it's a closed loop. But here, still now, there is no closed loops are formed. Okay, now we come to our session. Now we are connecting the elements B, F and the weightage is 4. Okay, in right hand side diagram, you can check B and F are connected and the weightage 4 is assigned for BF. Okay. Now we go for the next session. You can guess what is the value comes to the left. CF4, it comes to the left. Yeah, this is the next lowermost value. So I can move CS4 in the left. But in the center sorted tree, there is no need for changes. You just write the previous rest of the element. Only CF4 comes to left. The rest of the elements are AF5, FD5, CD6, AE6, DE8. So you can see your diagram. Still now there is no loops are available. Everything's are open. Okay. In the next session, CF is comes to left. Suppose if I am going to connect C and F, what will happen? Yeah, B, C, F make a loop. So what I am doing, my concept is if any loop occur or arise, we cannot choose the value. Yeah, you see the next tabular column CF4, AF, FD5, CD, AE, DE, there is no changes in the center column. In right hand side diagram, I never make a diagram. Why? I use the word kill CF. It will form a loop. Yeah, we go for the diagram. When I am connecting the C and F, what will happen? BCF form a loop. So that I kill this CF4. I think you are all clear about it. Once again, you check the next sorted tree element. What is the next one? AF5. The weightage is 5. This is also killed. Why? Suppose if I am connecting A and F, the weightage is 5. What will happen? A, B, F form a loop. Again I want to comes to a conclusion. When the graph comes to a loop, surely I never use the values, so that I go for kill and it will form a loop, so that I drop these two elements. Now I go for the next value FD5. This is the lowermost value. Okay. Next lowermost value. Now I am going to check the diagram. If I am connecting F and D, is it possible to make any loop? Then what I will do? I just kill the process. But you check my diagram. F and D connected and the weightage is assigned for F and D. There is no loop. It just form a line. So I never kill this F and D. I think you are all clear about it. Kruskal algorithm. If any closed loop formed, we just killed the loop, that element. Then we go for the next one. This is the basic concept. Okay, now we go for the total weightage of the fanning tree. Why we go for this total weightages? Finally, somebody asked, maybe some questions are raised. Why we never use this C, D and AE, the rest of the DE element? Okay, now we check this element. Suppose if I am connecting C and D, what will happen? B, C, D, F form a loop. So I killed it. Again you check A and E. What will happen? A, B, E, F form a loop. In my concept is, if any loop occur, you just killed it. Again, the last value DE. Suppose if I am going to connect these two elements D and E, what will happen? DEF, it form a loop. So again we want to kill it so that I never use this C, D, A, E and D. So my graph comes to end. Yeah, this is the final diagram. What are the elements are available here? A, B, C, F, D, E, N, F. The rest of the elements are killed because it form a loop. Okay, so now I collect the weightages from this diagram. In BC, it has a weightage 1 and AB, it has a weightage 3, BF, it has a weightage 4 and DF, it has a weightage 5, EF, it has a weightage 2. Now I chose all the weightages and all the weightages are added together. The total weight of the spanning tree is 1 plus 3 plus 4 plus 5 plus 2. What will happen? 15. This is the total weightage. I give an option to you. Initially we draw a graph. We take an example. What will happen? The total weightage is very huge. In my concept, the Kruskal algorithm is mainly used to find the minimum weightage of the spanning tree. So that I used this concept to find the minimum weightages. So what is the advantages for this Kruskal algorithm? This Kruskal algorithm is very simple to implement and can be used in a variety of scenarios, including the calculation of minimum spanning trees. So the main concept is applicable in minimum spanning trees. So it maintains all the vertices in the graph in the optimal solutions. So we can easily implement this Kruskal algorithm. There is no tough concept. So next we discuss about comparison between Kruskal algorithm with Prim's algorithm. Why I am comparing this Prim's algorithm and Kruskal algorithm? This Prim's is also used to find the minimum spanning tree application, but why I am choosing Kruskal algorithm is best. So initially it start to build the minimum spanning tree from any vertices in the graph for Prim's algorithm, but in Kruskal algorithm it start to build the minimum spanning tree from the vertex carrying minimum weight in the graph. So it can choose very minimum weightages in the graph. And in Prim's algorithm, it travels one node more than one time to get the minimum distance. But in Kruskal, there is no need. It travels only one time is enough to visit a node. So it travels one node only one time. That's enough. In Prim's algorithm, it gives a connected component as well as it works only on connected graph. Yeah, in Kruskal algorithm, it can generate forest. What is forest? It's a disconnected components. Yeah, already I explained in our concept. It never support closed loop. It's a disconnected path. So at any instant as well as it can work disconnected component. So Prim's algorithm runs faster in dense graph. Kruskal algorithm runs faster in sparse graph. It generates the minimum spanning tree starting from the root vertices, that is in Prim's algorithm. But in Kruskal algorithm, it generates the minimum spanning starting from the least weighted edges. In our tabular column, initially what we are doing, we assign all the vertices from the lowermost cadre so that it choose the least weighted edges. So application of Prim's algorithm or traveling salesman problem, network and road and rail tracks connecting all the cities, etc. So when we are comes to find a salesman problem, suppose if a salesman want to travel from one place to another, what will happen? He find a shortest path. So this is the algorithm. These algorithms are helped to find the shortest path for salesmen and network for roads and railway tracks. So every place's application, wherever we need to find the shortest path, we can go for this Prim's algorithm and Kruskal algorithm. Application of Kruskal algorithm or LAN connections. Do you know what is LAN? Local area network. Okay. In our college, lot of computers are available inside the laboratories. Okay. What will happen? Suppose we want to connect a local area network inside the laboratories, all the systems are connected. So this is very lower places, so that we can choose this Kruskal algorithm in LAN, local area network, TV network, etc. So application for Kruskal algorithm. The main application is for Kruskal algorithm is minimum spanning trees have different direct applications in the design of. In some other design application also this Kruskal comes to placed. The first one is computer network. Now in our life the network is the main role, and also telecommunication network, transportation network, water supply network and electrical grid. So these are all the application these Kruskal algorithms are applicable. So computer networks, we can connect a lot of systems, a lot of devices together. In communication also we need to connect and find the shortest path. So wherever to make the devices in shortest or minimum weightages, we can go for this Kruskal algorithm. So thank you all. I hope this session will helpful you to make this Kruskal algorithm very clearly in the concept. Thank you all.